this handout is for section 1-6 relations. I want you to make it face this way, and you're going to fold it in like this. And what we're looking at is the relationship between our x and y values and a table, mapping, and a graph. And tell whether it's a function or, if you fold the other side, not a function. Let's open it up. So right here what we have is a table, and on the table we have an x and y value. We can make up any points, but I want you to write -2, 2, 0, 3, 1, -1, 2, 4. And for it to be a function, what you're looking for is that the x values do not repeat. So as you can tell, none of the x values repeat. But it's more specific than that. We have to say that each x value is paired with one y value. So why are we making that distinction? Well, sometimes what happens is that we can rewrite a point. Let me do 0, and it looks like the x's repeat. But if we give it the same y value, it's sort of like a typo, and it still makes it a function. It's like you've written it twice. So it's still that each x value has only one y value. And I'm going to highlight the 1 because that's what we need. So on the table, what's not a function? On the table, not a function is when we have x values that do repeat. So let's write a table. These are your x and your y values. I have -3, -2, -1, 2, -1, 1, 2, -3. So this is not a function. The reason this is not a function is because the x values repeat. So this right here is the reason that this would be considered not a function. More specifically, we have the x value of -1 is paired with two values of y. And that's what makes it not a function. So what we're looking at here is it doesn't work. So just think about you in this class. I'm going to say that I'm going to give a project, and I'm going to assign you a partner. You are the x values. If I say that your partner is this person right here, and then I call somebody else, and then you're this person right here, and I say this is your partner, then I call your name again and tell you you have a different partner, that doesn't work. That doesn't function. So make sure that you only have one value of y to every value of x. These right here are called mapping. On mapping, we still have x and y values. And we're still looking for the same thing, that each x value is paired with one y value. So we're only looking for one for it to be a function. So all of these are on this side is a function. So from the table right here, we're going to write down the x values and the y values. For mapping, it's important to make sure that you write it from least to greatest without repeating. So from least to greatest, that would be -2, 0, 1, 2 for the x values. On the y values, it would be -1, 2, 3, 4. And then what we do is indicate which ones go together with an arrow. So -2 went with the +2 on the y. 0 went with 3. 1 went with -1. And 2 went with 4. So yes, we're looking for the x values to only be paired with 1, but in mapping, we're also looking at that one arrow goes from one x value. All right, so what makes it not a function? We still have an x and a y value. We write them down in order from least to greatest without repeating. So this one would be -3, -1, 2. On the other side, we would have -3, -2, 1, 2. So they look a little bit different than from the table, but then we make the connection, the arrow between which ones go together. So 2 went with -2, 1 went with 2, 1 also went with a +1, and 2 went with -3. So the problem was this. It doesn't look like the x repeat anymore, so that's why that's important. We want to look for that the x value is paired with 2 y values to make it not a function. This would be not a function. So if the x value is paired with 2 y values, that would make it not a function. That's a problem. So the other way that we could look at it is 2 arrows from one x value. So 2 arrows from one x value makes it not a function. So remember, everything on this side is not a function. I'm going to make a little side note. So I'm going to go from here to here. Make a little squiggle that is just a side note. And I want to tell you what domain means. Domain are x values. They are also written from least to greatest without repeating. They look like this. They have this little bracket notation. And we just write all the x values, -3, -1, 2. So in order from least to greatest and without repeating. And then you just make it again on the other side. And that's considered the domain. Domain is a very important word. We need to know it for this class. We're going to be asked several questions about the domain. And when it says domain, we're just looking for those x values. So what are the y values called? They're called the range. Range are y values. I'm going to highlight range. We're going to need that. There's several different applications to the word range. So it depends on the use and what is referring to. This is also from least to greatest. Without repeating. It's also with the little brackets. And so this one would be -3, -2, 1, 2. But we're just talking about the y values. The next thing that we're looking at is the graph of the same ordered pairs. So I'm going to graph these points. And so here's your x values. From 0 to this side is positive x values. From this side to over here is negative x values. From the top of this line up, these are y values and positive y values. And then these would be the negative y values. So when you have the ordered pair -2, 2, it's -2 on the x and a +2 on the y. The next point is 0, 3. So that means you stay on this line and go up 3. 1, 2, 3 of the y-axis. The next point is 1, -1. 1 on the positive x and then -1 on the y. So the point goes right here. And then 2, 4. That's 1, 2, 3. Oh, 1, 2. And then up 4. 1, 2, 3, 4. And that would be the graph of this ordered pairs. What we wanted to do is pass the vertical line test. So what's the vertical line test? We need to know what this is, so I'm going to highlight it, that it's actually just a line going vertical. It's supposed to be tested at every point on the graph. So we got to test them at every point on the graph. But what does it mean to pass? To pass this test? To pass a test means that the vertical, and I'm going to make a little parentheses that a vertical line goes up and down. The vertical line touches the graph only once. So the phrase that we use is vertical line test, but it's actually a whole bunch of times that you're supposed to check it. And so it's many lines that we have to test out. So because it only touched once, only touch once, only touch once, only touch once, it passed the test. So let's see what it looks like to fail the test. We're using the points from this table right here. The first order pair is -3, -1, 2, 3, and then down 2, -2, 1, 2. The next one is -1, 2, 1, 2, and then -1, up 1. The last point is 2, 1, 2, and down 3, 1, 2, 3. We're still trying to do the vertical line test, But the only one that I'm going to highlight this time is this one, because that's how it fails the line test. So this graph does not pass. This graph does not pass the vertical line test. Why not? I'm going to make a little arrow like this so you know that that's what I'm referring to. Why not? It's because that one vertical line touched more than once. The vertical line touched the graph more than once. It can touch it a whole bunch of times actually, but it just needs more than once to fail the test.